What's going on? It's your old pal, Mr. Cook, and we're going to work on the information that we have in section 9.4, the normal distribution and the normal distribution curve, and the information that we can gather from it. It's really helpful to have a calculator for this stuff because, sometimes you got to multiply things or divide things, and just having a calculator handy is pretty helpful to, kind of alleviate some of the stress that's involved with that. Okay, so anyways, normal distribution is when the data tends to spread out, or if it's distributed around a central value. That's really important, a central value, with no biases left or to the right. So normal distributions are really, really cool. Like, they're ideal for different situations like standardized tests, like the SAT and the Easy Merit and all that kind of stuff. It's because there's a lot of symmetry involved, and also it helps to show that, not a lot of people fail, not a lot of people do really well. It's a lot of, and it shows exceptional kind of stuff, which is pretty neat. So types of distributions. It can be spread out more on the left, or it can be spread out more on the right, or all jumbled up. So when it's spread out specifically to the left or to the right, we call those skewed distributions. So that's what these little terms down here mean: skewed to the left and skewed to the right. But what is skewed to the left? Well, if we look at the distribution, if we kind of draw a little curve around it, it looks like it comes up with like a little tail at the end, and the majority of the stuff's over to the right. Wherever the little tail is pointing, that's the direction that it is skewed. So if you see on like this curve over here, if I were to draw it out a little bit more, curve-like, the tail, the lower part of it, points over to the right. That's why it's skewed to the right. So just remember that when it's skewed to the left or the right, all you got to do is just look at the little tail there, okay? All right, and then this one's all jumbled up. This one's crazy. Look at this distribution. Kind of looks like a hand or something like that you used to draw when you were in like first grade, right? Not great, and a lot of ups and downs and all that kind of stuff. So we say that this doesn't really have any specific bias left to right, and it's just no real like defined distribution there. So this is why normal distributions are really cool. It's because the mean is equal to the median, which is equal to the mode. This stuff like shows up in nature occasionally, but like not too often when we want it to, so we can force things to be normalized, based off of our knowledge of statistics. So because I mean, think about it, the mean, the average, needs to be the same as the median, the middle value, and also the mode, which is the most frequently occurring value. That's not always going to be the case where all of these are the exact same value, because remember, that's what that equals mean. It means that it has to be the same, not really close. It has to be exactly equal. And you guys have seen like when if test scores are really low in some like really difficult classes, or even in like easy classes when tests are really difficult, they tend to grade on a curve. Have you heard that expression, to grade on a curve? Well, what they do is they take data that's kind of all over the place or skewed to the left or the right, like these different things here. And what they do is they turn it into a nice little normal distribution, like this yellow one over here, where this mean value, the one that's in the middle, is the most frequently occurring value. And then everything to the right and the left is, symmetric about that. So this truly does represent like a nice little average or snapshot of the average person that's in the classroom, that mean value. That's what grading to a curve represents. So a nice thing about a normal distribution is that it's symmetric over the center. Remember what symmetric means? It means that it's the same. So it's the same over on this side, on the left of that central value, and the same over on the right. That means that it has symmetry. And it also implies that if they're the same, that it has pretty close to about 50% of the data on the left-hand side of this under the curve. So all this stuff, about 50% of it under the curve. And then 50% of it over here as well on the right-hand side of that mean or the median in the mode. So that's pretty neat too. That's why normal distributions are really widely, necessary for those things like standardized tests and whatever. Okay, so let's see here. I think that's about as far as I want to take this video, and then we'll start up on interpreting a normal distribution and the different key parts of it in the next one. So yeah, a nice little short and sweet video on this first part of 9.4. And then, if you have any questions, don't hesitate to go over to your teacher's office hours and ask away. All right, that's it for now. Thank you very much.